Welcome to the arena. Seriously, step right into the Coliseum of Cambridge exams. Every single year, tens of thousands of students walk into their mathematics paper, sitting at those wobbly little desks, but only the truly prepared survive with those top-tier, life-changing grades. We are talking about the Cambridge 0580 syllabus today, though. Listen, these exact same, ruthless, highly tested survival tactics apply whether you're tackling 0606, 4024, 4037, or even 4040. My name is your chief strategist, and today, in this explainer, we are going to secure maximum marks on two of the absolute most heavily penalized topics in the entire syllabus: scale drawings and bearings. Okay, let's dive into this by looking at two typical students we see every year. Picture our first student, Alex. Alex is the classic overthinker. Alex overloads his past paper with raw mathematics facts, writing out massive paragraphs of unnecessary ratios, completely missing the actual analysis, and overcomplicating incredibly simple geometry. When the examiner gets Alex's paper, it just becomes a messy sea of red pen marks. Now look at Sam. Sam is in an absolute rush. Sam skips the command word requirements entirely, eyeball guesses the angles instead of actually measuring them, and drops 3 massive marks on what should be a straightforward 4-mark question. I mean, that used to be me, and honestly, it might be you right now. But today we are transforming those red marks into glorious green check marks. We are going to decode the examiner's mind and build a bulletproof system. So, here is your visual syllabus for today's masterclass. This is exactly what we will be conquering step by step. First up, decoding scale drawings, finding out what the examiners are actually hiding in plain sight. Second, calculating real distances without falling into the classic unit conversion trap that gets Sam every time. Third, the rules of bearings, where we will lay out the non-negotiable laws of direction. And fourth, the absolute final boss of geometry, finding reverse bearings. Let's get straight into it.
Let's transition right into our first crucial pillar, decoding scale drawings. Listen, when you look at a scale drawing in an exam, the command words are literally everything. Words like calculate, measure, or determine. These aren't just polite suggestions. They are explicit, rigid instructions telling you exactly how many steps you need to take. To beat this, we're applying the PL framework. Yes, we use it for math too. Point, evidence, explanation, link. Your point is establishing the scale rule. Your evidence is the raw measurement you take from the paper. Your explanation is showing the actual multiplier calculation, and the link is tying it back to the real-world units the question asked for. This is how top students structure their answers. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the foundational rule of scales.
The crucial baseline rule you have to internalize is incredibly simple. A scale drawing is exactly the same shape as the original drawing, but is entirely different in size. It sounds so basic, right? Like, yeah, I know that. But you would be absolutely shocked at how many marks are lost because students like Sam forget this baseline rule in the heat of the moment. Large objects like buildings or cities are scaled down proportionately just so they can fit onto the page of your exam booklet. When you see a ratio on the page, say 1 centimeter to 2 meters, what the examiner is secretly testing is your brain's ability to hold 2 different reality planes at the exact same time. You've got the paper reality and you've got the physical reality. Alex totally messes this up by trying to mathematically convert meters to centimeters before even touching the paper with a ruler. No, we need to keep it simple. The shape remains constant, only the scale changes. Let's put this theory to the test with a real past paper style scenario. This brilliantly illustrates the concept. Behold, the truck scale challenge. We have a scale drawing of a truck right here, and the examiner explicitly gives us the scale at the bottom, 1 centimeter to 2 meters. The command word implicit here is to calculate the real length of the truck. Let's walk through the exact steps you need to take using our framework. First, identify your scale. 1 centimeter equals 2 meters. That's your point. Next, your evidence. You must take your physical ruler, and yes, actually bring a clear plastic ruler into the exam coliseum and measure the length of the truck on the paper. Let's say you measure it, and it's exactly 4 centimeters. Now, the explanation. We show our working. Since 1 centimeter represents 2 meters, we multiply our drawing length, 4, by our scale factor, 2. Finally, 4 times 2 equals 8 meters. And the link. We link it back to the real world by writing the unit meters. Look at the second part of this challenge. The examiner asks, will the truck go safely under a bridge that is 4 meters high? Well, we measure the truck's height on the drawing. Let's say it's 2.5 centimeters. 2.5 times the scale of 2 is 5 meters. The bridge is 4 meters. The truck is 5 meters. Bam! The truck will absolutely not fit. By explicitly showing your measurement and calculation, you guarantee yourself full marks even if your hands are shaking and you make a tiny arithmetic error along the way.
Let's distill that down into pure strategy. Here is your ultimate 3-step actionable framework. Step 1. Measure on the drawing. Step 2. Multiply by the scale. Step 3. Change the units to real life. Imagine we are rewriting Alex and Sam's flawed answers live right now using these exact 3 steps. Alex wrote a massive, rambling paragraph of confusing ratios. Nope, we crossed that out. The red pen turns to a glowing green check mark as we replace his essay with just 3 lines of clean, structured math. Now for Sam. Sam just guessed the length by eyeballing it. We cross that out entirely. Red pen transforms to a green check mark as we explicitly write down the physical measurement of 4 centimeters to secure that evidence mark. This right here is the mathematics success blueprint. When you structure your answers like this, the examiner has literally no choice but to award you every single mark. Stop strolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's see how this builds as we level up and enter Section 2, Calculating Real Distances. We are graduating from basic trucks to entire geographical maps. Now, the visual complexity is going to increase, but don't panic, because the framework remains your absolute shield. Welcome to Challenge 1, the data scan. I want you to imagine a 60-second visual countdown timer on your screen right now. Look at this map of Southeast England. You see London, Reading, Southampton, Brighton. You're scanning the complex data to extract the core trend. The scale given is 1 centimeter to 20 kilometers. The question asks for the real-life distance between London and Reading. Go. When Sam sees a question like this, the panic immediately sets in because the line isn't already drawn for him. But a top-tier strategist doesn't panic. You grab your ruler, you draw a faint pencil line connecting the exact center of the red dot for London to the exact center of the red dot for Reading. You measure it accurately. Let's say it comes out to 3.2 centimeters. You apply the blueprint. 3.2 multiplied by the scale of 20. That gives you 64. You check your units for the linked kilometers. The answer is 64 kilometers. Timer finished. Easy marks. But what if the exam works backward? What if they say it is 90 kilometers from London to Cambridge? How many centimeters will this be on the map? You just reverse the blueprint. Instead of multiplying, you divide. 90 divided by our scale of 20 equals 4.5 centimeters. It is mathematically beautiful when you just follow the steps.
Pivot with me now, high energy, as we enter Section 3, the rules of bearings. Listen to me closely. This is the exact spot on the 0580 syllabus where thousands of students needlessly hemorrhage points every single year. They just throw marks away. We are going to stop the bleeding right now.
I need you to put on your examiner's lens for a second. Read these 3 bullet points. Memorize them, tattoo them on the inside of your eyelids. Bearings are used to describe direction, and they follow 3 absolute non-negotiable laws. Rule 1, they are always measured clockwise, never anti-clockwise. Rule 2, they are always measured from north. You must have a north line drawn at your starting point. Rule 3, they must have 3 figures. Listen, this third rule is the ultimate trap. If your angle is 70 degrees, you do not write 70. You write 070 degrees. If you just write 70, you lose the mark, period, end of story. The examiner is literally testing your discipline with that leading 0. Sam always forgets the 0 because he rushes. Don't be like Sam. Let's move to Challenge 2. Find the flaw. Look at this diagram. We need the bearing of B from A. The wording is crucial here. From A. That command word tells you A is our starting fixed point. Do you see the north line at point A? Good. Now, imagine putting your protractor exactly on point A, aligning the 0 line perfectly with the north arrow. A 60-second timer is ticking down in your head in the exam hall. You scan clockwise until you hit the line connecting A to B. Let's say you read the protractor, and the angle is exactly 70 degrees. Now here is the flaw challenge. Let's say Alex writes down a perfectly structured Peel paragraph, but his final sentence is, therefore, the bearing is 70 degrees. Time's up. What's the flaw? The sentence losing him the mark is missing the third figure. The absolute correct answer, the only answer the examiner accepts, is 070 degrees. And another quick examiner tip. Make sure you use the clockwise scale on your physical protractor. If you read the inner anti-clockwise scale by mistake because you're rushing, you will write down a completely disastrous number.
Take a breath.
We have reached the final and often the most intimidating concept of the entire syllabus: finding reverse bearings. This basically means calculating the direction from where you just came. So, if the bearing of B from A is 070 degrees, what is the bearing of A from B? It sounds like an impossible riddle, but I promise you it's just pure logic.
I want you to burn this number into your memory: 180 degrees. This number is the absolute magic key that unlocks all reverse bearing calculations. Why 180? Well, because north lines are parallel. When you draw a line between 2 points, the interior angles between those two parallel north lines always add up to exactly 180 degrees. It's just basic parallel line geometry disguised as a complex navigational problem. Once you understand that 180 is your ultimate weapon in the arena, you can solve literally any reverse bearing question in under 10 seconds. Let's practice the actual cheat code. Here it is, a foolproof comparison. If the original bearing you are given is less than 180 degrees, you simply add 180 degrees. Conversely, if the original bearing is greater than 180 degrees, you subtract 180 degrees. It is an incredibly simple either-or comparison. Let's walk through it together. If your original bearing is 070, well, 70 is less than 180, right? So we add 180 to it. 70 plus 180 gives us 250 degrees. Bam! 2 marks secured just like that. What if the bearing they gave you was 290 degrees? Well, 290 is greater than 180, so we subtract. 290 minus 180 is 110 degrees. This rule makes getting the correct answer almost completely automatic. No guessing, no drawing complex alternate angles. Just trust the math.
Welcome to Challenge 3, Speed Writing. Look at this complex exam sketch. We have Town A, Town B, and Town C. B is 20 kilometers from A on a bearing of 085 degrees. C is 15 kilometers from B on a bearing of 150 degrees. I'm putting a 30-second timer on the clock for you to write one perfect peel paragraph explaining how to draw this. Look at how Alex handles this. He draws a chaotic, messy web of lines, mixing up the distances with the angles, totally losing the plot and losing the marks. Now look at the blueprint answer. We start with point A. Draw a north line. That's your point. Measure exactly 085 degrees clockwise. Draw a faint line. Then, use your scale. If the scale is 1 centimeter to 5 kilometers, that 20-kilometer distance means drawing a line exactly 4 centimeters long to find Town B. That's your evidence and explanation. Now, at Town B, what do? You draw another north line. This right here is where Sam failed. He measured from the previous connecting line instead of drawing a fresh north line. Draw north at B. Measure 150 degrees clockwise. The distance is 15 kilometers, so divide by 5 to get 3 centimeters. Draw a line 3 centimeters long. Boom, you found Town C. If the final question asks for the distance of A from C, just connect the dots, measure the line in centimeters, and multiply by 5. If it measures 5.9 centimeters, 5.9 times 5 is 29.5 kilometers. Combining scale drawings with bearings is entirely manageable when you systematically apply the rules one step at a time.
Look at that progress bar reaching 100%. You have mastered the system. Here is your ultimate cheat sheet summarized directly from the Cambridge guidelines. Rule 1 for command word decoding and scales. Scale maps mean one unit on paper represents a specific number of units in real life. Measure, multiply, convert. Rule 2 for bearings. They are always 3-figure angles measured clockwise straight from the north line. Rule 3. Use the magic 180 degrees for reverse bearings. Add if it's small, subtract if it's large. This is your complete mathematics answering system. Now, listen to me. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with this final, provocative thought staring you right in the face. Picture it. When you are sitting in that dead silent exam hall, your heart is beating fast, the clock is ticking down, and your protractor reads exactly 65 degrees. Will you remember to add the leading zero? Will you confidently write 065, or will you let the examiner steal a mark you worked so incredibly hard for? The choice, and ultimately the grade, is entirely yours. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, trust the framework, and I will see you in the next masterclass.